Let me read the question 13 part A. Diagram 9 shows angle theta on a Cartesian plane. Okay, for the part 1, on diagram 9, label the position of negative theta. For the part 2, state the value of tangent negative theta in terms of P and of Q. Okay, within this question 13, actually we have 3 parts. Part A, Part B and Part C. We have already looked at the Part A. Let us look at the Part B now. Let me read the question 13 Part B. Solve the equation 2 cos x equals to sec 3 cotangent x for 0 degree less than equals to x less than equals to 360 degree. Okay, so this is the question 13 part B. Let me read the question 13 part C now. Let me read the question 13 part C now. It is given that tangent M is equals to P such that M is a reflex angle. Express cos in a bracket pi minus 3 minus M in terms of P. Okay, so this is the oral question 13. I hope you could manage to solve this question. Okay, so take your time to solve this question and we will begin our discussion in a count of 5, 4, 3, 2, 1. Let us begin our discussion for the question 13, where we need to label the position of negative theta and state the value of tangent negative theta in terms of P and Q. As you can see here, I have literally sketched the diagram 9 for you, where you can see the coordinate PQ and the positive angle theta over here. Okay, you can have a positive angle theta when your angle is moving in a counterclockwise direction. Okay, whereas you can have a negative angle if your angle is moving in a clockwise direction. Okay, I hope I am able to clarify you guys. So from here, to get the negative theta, what you're going to do is, okay, let me just sketch this. Okay, just give me a moment. Okay, let's say this is your negative Q. Okay, let me just sketch a line here. So from here, this is your coordinate P, negative Q, and you have an angle negative theta. Okay, because your angle is moving in a clockwise direction for the negative angle, whereas for the positive angle, it's moving in a counterclockwise or anti-clockwise. Okay, let me just label the x coordinate over here. Okay, so to understand better, so let me just indicate the direction of the angle movement, which in a clockwise. Okay, so this is the answer for the question 13A part 1. Okay, so this is for the question 13A part 1. Okay, let us move on our discussion for the question 13A part 2, where we need to state the value of tangent negative theta in terms of P and of Q. Okay, so from here, tangent negative theta, so we have already get the triangle here. So from here, this is the angle negative theta, and just imagine this as a right angle triangle. Okay, if you can't imagine this, let me just help you to draw the dotted line so you can see it clearly. Okay, so let me just draw a small 90-degree angle. Okay, so from here, so we need to find the tangent of negative theta in this case. Okay, so remember guys, the formula for tangent theta is actually opposite divide with adjacent. Okay, so from here, in this case, the opposite of this angle is actually the distance of the vertical distance. In this case is negative Q. Okay, the vertical distance in this case is negative Q. So just write here negative Q over here. Okay, and then divide with the adjacent. Okay, in this case, the adjacent is the x coordinate, which in this case is the P. So this is your tangent negative theta, guys. Okay, this is your answer for the question 13A part 2. Okay, it's a very short discussion. Okay, so from here, let us proceed our discussion for the question 13 part B. Let us begin our discussion for the question 13 part B. Okay, so let me write the equation now. So from here, 2 cos x equals to sec3 cotangent x. Okay, so from here, so to proceed for the next step, what you're going to do is we're going to try to make it similar for two equations. So from here, cotangent x we can simplify in terms of cosine x, which in this case cotangent x we can simplify into cos x divided with sine x. Okay, so we can modify the cotangent x so that it will be similar with the left hand side equation. Okay, so from here, 2 cos x, okay, equals to sec3, okay, times with cos x divided with sine x. Okay, so to explain this, so cotangent is actually 1 over tangent x. Tangent x is actually sine x divided with cos x. So from here, 1 over tangent x is actually equals to cos x over sine x. You just flip this, guys, this fraction of trigonometry. Okay, so from here, to proceed for the next step, what you're going to do is we're going to eliminate this fraction. So how are you going to eliminate this fraction? So let us times sine x in both side equation. So from here, times by sine x. So from here you get 2 cos x sine x equals to sec3 cos x. Okay, so far so good. For the next step, what you're going to do is, so this sec3 cos x from the right hand side, we're going to move it over to the left hand side. Okay, so from here, 2 cos x sine x minus with sec3 cos x equals to 0. Okay, for the next step, what you're going to do is we're going to factor out the cos x. Okay, so we factor out the cos x, we only left with 2 sine x minus with sec3 close bracket equals to 0. Okay, up until now I hope you guys are clear. So from here we're going to have a two concurrent working, guys. Okay, so let me split into two. So from here you will have two possible solutions. Let us start with the cos x. So from here, cos x, okay, you can have equals to 0, and over here you have 2 sine x minus sec3 equals to 0. So when you move this negative sec3 to the right hand side, you get 2 sine x equals to sec3. Okay, so from here, to get your sine x, what you do, sec3 you divide with 2, so you're left with sec3 divided with 2. Okay, so far so good. So from here, let us begin our solution for the cos x. So from here, to get your angle equals to 0, so you get your x is actually, your angle x will be actually equals to 90 degree. Okay, please wait, guys. Equals to 90 degree. Okay, cosine inverse 0 is 90 degree. Okay, but remember that we are looking for range of 0 degree up to 360 degree. So cosine is positive in first quadrant and fourth quadrant, guys. Okay, so from here, first quadrant is 90 degree. For the fourth quadrant, okay, you need to add another solution. From here, 360 degree minus with 90 degree. Okay, so from here you left your x equals to 90 degree, okay, and then 270 degree. Okay, so this is first set of answer. Okay, so let us proceed with this one. So from here, sine x, you get this sec3 over 2. So from here, you get your x angle is equals to 60 degree. Okay, this angle we can able to get using the triangle method, guys. Okay, I will show you the sketch of the triangle, okay, in the image now, so you can use that as your reference. Okay, so from here, so sine inverse SUB3 over 2 you get is 60 degree, and you should know that sine is actually positive in first and second quadrant. So we have already write the angle for first quadrant, so now we need to write the angle for second quadrant. So for second quadrant is 180 degree minus with 60 degree, close bracket. So from here you get your x is equals to 60 degree, okay, and then 120 degree. Okay, make sure you write the second solution also, guys, otherwise you're not going to get the full marks. Okay, oops. So from here your final answer will be x is equals to, okay, 60 degree, okay, and then comma 90 degree, okay, and then comma 120 degree, okay, and then comma 270 degree. So this will be your final answer, guys. Okay, so from here we are done our discussion for the question 13 part B. Let us proceed our discussion for the question 13 part C now. Let us proceed our discussion for the question 13 part C. Okay, so let us begin to solve this question. Okay, the question gives us that tangent M equals to P and M is actually a reflex angle. Okay, so let us write the information. Okay, given that tangent M equals to P. Okay, and since tangent M is a reflex angle, so we can conclude that the angle is actually bigger than 180 degree. So what I'm going to do now is I'm going to sketch a quick Cartesian plane. Okay, so from here, the reason why I'm sketching a Cartesian plane, so that it will be easier for us to imagine and it will be useful for our working as well. Okay, so this is the y-axis, this is the x. Okay, this is the origin. Okay, and remember that your angle is actually reflex. So this is your angle M, and since tangent M, the M is positive, so the movement is counterclockwise. So from positive x up until here, so it moves in a counterclockwise direction. Okay, for the next part you're going to do is we're going to form a triangle, like a right angle triangle, like a shape over here, since they mentioned that tangent M is equals to P. Okay, and since they mentioned that it is a reflex angle, so we can conclude that the location is actually located in the third quadrant. Okay, third quadrant, you can conclude that your x and y will be negative in this case. So from here we can make a quick prediction that your position of this triangle, okay, the distance of horizontal and vertical, okay, we can conclude this as negative P. Okay, and this x coordinate is negative 1. Okay, so this small angle we write as M as well. Okay, so in order for the better understanding. Okay, so from here the vertical distance is negative P, the horizontal distance is negative 1. So the next step, what you're going to do is you're going to find the hypotenuse. So how you're going to find the hypotenuse? Very simple, guys. We're going to use the Pythagoras theorem, which in this case is negative P square plus with negative 1 square. So from here, negative P square plus with negative 1 square, and then you square root it. So from here you'll get your answer in this case will be 1 square plus with p square square root. So in this case will be 1 plus with p square square root. So this would be your hypotenuse. Okay, so let me show the arrow that this square root 1 plus p square is the value for hypotenuse. Okay, so from here let us proceed our discussion. Tangent m as given by the question is equals to p, but then we can also prove it directly from here using the triangle method, which in this case is opposite over adjacent. So this is the angle, okay, the opposite of this angle, okay, is the vertical distance, in this case is negative p, okay, divide with the adjacent, okay, divide with negative 1. So that's how you get tangent m is equals to p. Okay, actually the question already gave us the hint, guys. P is actually a reflex angle, so that's the reason why I put the distance of horizontal and vertical is negative p and negative 1 respectively. So I hope you understand what I mean, guys. Okay, so we have already find the first basic trigonometry. So let us proceed to find the next two basic trigonometry, which is sine and cosine. Okay, so from here let us start to find for the sine. Okay, why I'm finding the three basic trigonometric identities, there is a reason. Okay, I'm going to talk to you about that later on. I'm going to explain to you later on, so please stay with me, guys, regarding the explanation. So from here we find sine m. Okay, so from here sine, the formula is equals to opposite divide with hypotenuse. Okay, in this case your opposite is actually negative p, okay, and then you divide with the hypotenuse, square root 1 plus with p square. Okay, this is your sine m. So for cosine m, okay, is equals to adjacent over hypotenuse. So in this case, the one adjacent with the angle, the distance is actually negative 1. Okay, and then you divide with the distance of hypotenuse, adjacent over hypotenuse. So in this case, square root 1 plus p square. Okay, so this is the reason why I recommend the students to sketch the basic Cartesian plane, and then from here you form a right angle triangle. And once you already form the distance, the vertical and horizontal distance, and you find the hypotenuse, the rest is very simple, guys. You can just straight away find the trigonometry basic trigonometry identities, which in this case the tangent, sine and cosine. Okay, so for the next step, what you're going to do is, since the question asks us to express cos in a bracket pi minus 3 minus m, okay, so from here we're going to use the compound angle formula. Okay, so by using the compound angle formula, okay, by the way, if you don't know what is the compound angle formula, I'm going to show you in the explanation now, so you can have a look at that and you can refer that as your reference, so in order for to solve this step. Okay, so from here, so it will be equals to cos pi over 3 cos m plus sine pi over 3 sine m. Okay, can you see that we need to apply the cos m sine m over here? So this is the reason why I ask you to find three component trigonometric component. Actually this first one is already given by the question, but it is important for us to find the balance too. Okay, because later on we're going to use the compound angle formula, and we have already found the expression in terms of sine m and cosine m. So now it will be easier for us to solve this following expression. Okay, so from here let us proceed our working. So from here, cos in the bracket pi over 3 minus m equals to, okay, cos pi over 3, So you key in your calculator, or you can use the right angle triangle method. So from here you can get your cos pi over 3 is actually 1 over 2. Okay, and then cos m is actually negative 1 over square root 1 plus with p square, which we get over here. Okay, and then plus with sine pi over 3. Okay, sine pi over 3 is also known as sine 60 degree. Okay, so from here it is actually sec 3 over 2. Okay, and then times with, okay, using this sine m value, negative p in a bracket square root 1 plus with p square, close bracket. Okay, so sorry guys if my handwriting is getting messy. Okay, so from here let us times in. So from here negative 1 over 2 square root 1 plus with p square. Okay, and then minus with square root 3 p divide with 2 sec 1 plus with p square. Okay, so we combine these two together. So from here you get negative sec 3 p minus 1. Okay, let me make this clear guys. Okay, this is the p is actually separated from the sec, it's not combined guys. Okay, so be careful. Okay, and then divide with 2 sec 1 plus with p square. So this is your answer for question 13 part C. Okay, so that is all for the step-by-step working and solution for this question. I hope you find this video useful. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming Math tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.